All right, let's get going. Thank you so much to Miss Montgomery for helping out today. So I think you're on that side of the room. High five. I think kind of like that. And sorry I can't be with you all today. I trust that I know at this point this is the end of the day getting for y'all, either fifth or eighth period. But I trust that y'all have been respectful and responsible as you should all day long. I also trust that you have already checked your homework from the last couple of days and that all of that is in. So what we're going to do today is I'm just going to walk you through, just like I was there, obviously just a hair different since I'm in this setting. We're going to walk you through more about factoring trinomials. We're going to do the rest of 6.2 today. So I'm going to go ahead and share my screen. I have a copy of the book in electronic format here. So if you go over to page 439, if you're so inclined, certainly have your notebooks out. Be sure that you take notes. And we are going to start here, example 5. I'm going to work out the examples over here on the right side of my screen, and then you can follow along. So what we're going to do starting in example 5 is we're going to be deciding whether or not polynomials are prime. So again, remember what a prime number is. It's a number where you can't, you don't have to write this down. The number 11, we're going to see this in a minute, is prime because the only numbers you can multiply to get 11 are 1 times 11. Nothing else, no full numbers will multiply to give us the number. So it's going to be the same thing here. When we factor a polynomial, if there are no polynomials that we can multiply together to get our trinomial, then that trinomial is prime. All right, so let's see this in action. Let's take this first example of x squared minus 5. Oh, gotta pull my x squared minus 5x plus 12. All right, so obviously I'm right here on example A. So if we were to start with step number 1 of factoring our 12, right? Factors of 12. So what are the factors of 12? So it should be, well, 1 times 12, and then 2 times 6, and then 3 times 4. That's all of our factors of 12. So we've done this a million times before. Now you want to ask, how do we get to negative 5? And again, we can figure we want the negatives to be 1 and 12, 2 and 6 and 3 and 4. Which of those add together to get 5? Of course, the answer is none of them. You can't add any of those. So because none of these factors will add to give us our middle term, we're going to say that this is prime. That is a prime trinomial. All right, let's do another example real quick. Let's look at example B. And let's make this one from here, k squared. What is it? Minus 8k plus 11. So again, what we're going to do, we're going to check our factors. We're going to factor 11. Why? Because that's our third term. So what are the factors of 11? 1 and 11. That's the only thing because 11 is also a prime. So is there any way we can add 1 and 11 to get negative 8? And of course, the answer is no, which tells us this entire polynomial is prime. So this trinomial is prime. It's not going to let me put on the same line. That's okay. Okay, so that's all I want you to see for example A is that they will be prime if your third term cannot be added together to make the factors of the third term can be added together to get the middle term. Let's go on to example 6. Example 6. So here we're going to have z, well, what are we doing in example 6, just to be clear? We're going to be factoring a trinomial, and here trinomial with 2 variables. So all the ones we've seen so far, x squared, 5x, that's all a single variable, just the x. What happens when you have 2 variables? Well, not much different is going to change. So let's say we have z squared. Let's see, minus 2bz. That's those 2 right there, 2bz. Those are our 2 variables we're talking about, minus 3b squared. All right, so how am I going to factor this. It's the exact same process. I'm just going to look at this over here. What are the factors of negative 3b? Well, you're obviously going to have negative 3b squared. I'm sorry. Negative 3b times b would give us negative 3b squared. And b times, well, I'll say 3b again. 3b times negative b. Those are the factors that would give us either one of, there's nothing else that'll work, right? That's the, so having known to solve our factors, we're just going to do the exact same thing. Which of these two can we add together to get negative 2bz? Well, it looks like negative 3b, and I'll change that to green so you can see it. And it make much difference. Negative 3b and b, we can add those together to get negative 2b. Well, what about the z, Mr. Morrison? Well, keep in mind, whenever we did these before, all we were looking at was the coefficient in the front. The x, like in this case, is going to be taken care of by the x over here. This z is going to be taken care of by the z over here. We're just trying to get the 2b part. So negative 3b plus b will give us negative 2b. So we're just going to say the answer is z minus 3b times z plus b. And why plus b? Because that's a positive. And sure enough, that's what the answer has in your textbook. All right. So again, same process in that case. All right, let's move on down, I think, to our last example. Yeah, example 7 is going to give us 2. Now we're going to factor a trinomial with a common factor. Down on the next page, so it's all nice together. Not that it terribly matters. All right. So example A. So let's just work this out. 4a, and we're going to the 5th here, minus 28x to the 4th plus 40x to the 3rd. Now, we have two problems here. First of all, I would assume you don't want to try to find the factors of 40 that add up to get 28. And even if you do, we have this problem with the very first term has a coefficient greater than 1. We've not seen that. We're going to get to how to do that actually tomorrow. But in the meantime, what you should notice is just look at these. 4a to the 5th. I changed that to, should be x, not a. 4x to the 5th, negative 28x to the 4th, and positive 40x to the 3rd. You should immediately be able to see that there's a greatest common factor. What will go into 4 and 28 and 40? Well, obviously, 4 will do that. So 4, and then of our x to the 4th, I'm sorry, x to the 5th, x to the 4th, and x to the 3rd. What'll go into that? Well, x to the 3rd. So our greatest common factor between these 3 terms in the polynomial, we've done greatest common factors, is 4x to the 3rd. Now I'm just going to divide like I always do. What is 4x to the 5th divided by 4x to the 3rd? And you guys sure to be shouting out in the room, it's going to be x squared. All right. And then what is negative 28x to the 4th divided by x to the 3rd? Well, negative 28 divided by 4 is going to be negative 7. Oop, I already have a negative there. Negative 7. And then that's going to just be an x, right? And then 40 divided by 4 is obviously going to be 10. And the x to the thirds cancel out. So now we're not quite done, because now I can factor the x squared minus 7x plus 10. Let's take my factors of 10, which are going to be 1 and 10, and 2 and 5. So what can I add together of my factors to get 7? Well, 1 and 10 won't do it, but 2 and 5 will. I need a negative 7. So I need a positive 10. If I make both of these negative, then negative 2 plus negative 5 is going to give us negative 7. And now we have our answer. So let's include our, let's put our negative back. And so our answer is going to be, let's include our greatest common factor, 4x to the 3rd, times, oops, 4x to the third times, what's it going to be? X minus 2 times x plus 10. You see, I have my greatest common factor here. And then I have my x that I brought across, and I have my -2. And oh, you guys should be yelling in the room. That should have been -5, and then -5. So here's the answer: x 4x to the third times x minus 2 times x minus 5. And sure enough, that's what the book has as well. Let's do our last example, and then we'll be done. Example B. And here the example is going to be -3y to the 8th minus 18y to the 7th. Let's put that back on. Thank you. Plus 21y to the 6th. All right. So again, we want to look here and recognize that there's a greatest common factor that we can factor out of the three terms. What's the coefficient that'll go in? -3, -18, and +21. We can factor out that -3, and we do want to pull that -1 out. We definitely want to pull the negative out in this case. So -3, and then what is our exponent? Well, y to the 8th, y to the 7th, y to the 6th. You should all know it's y to the 6th is what has to come out. And now we're just going to divide our terms. What is -3y to the 8th divided by -3y to the 6th? Well, that's just going to be the negative is going to cancel out, y squared. All right. And then -18 divided by -3 is going to be +6. And then y to the, that'll just be y, because y to the 7th divided by y to the 6th is just going to be y. And then 21 divided by -3 is going to be -7. And then y to the 6th and y to the 6th are going to cancel out. So we should now have y squared plus 6y minus 7. Now, we can then factor this, and you should already be working ahead and seeing what are the factors of -7, and you should know they're 1 and 7, and that's just it. One of them has to be negative since it's a -7. So what do I add together to get +6y? Well, then I have to make this one the negative, -1 plus +7. And then let's just include everything for the end. Let's put this all on the same page again. So there we go. And now let's take our greatest common factor, start with that, -3y to the 6th. And what are we multiplying it by? We have y times -1, or y plus -1, y minus 1 times, and then our 7, y positive 7. And does this check out? Is what our book has? -y 3 to the 6, y plus 7, y minus 1. Yes, it does. So we got it right. So at this point, I hope you're seeing the process isn't really any different when you have to factor out something. Just pull the greatest common factor out first, and then treat this just like we have been doing the entire time. So the process here is any different. Once again, very, very quickly, if you do not have your factors of your third term cannot be added together for your second term, it's going to be a prime polynomial. If you have two variables in it, then you're just going to factor out the third term, multiply it just like you had. It's exactly the same procedure. And sometimes if you have big numbers, check and make sure you can't pull out a greatest common factor first. Once you have the greatest common factor, then factor the trinomial just as you always did. With that being said, I have given your your homework there, and I'm pretty sure just by memory, I think this is the exact same version of the textbook as you have. I think I gave you 27 through 66 on the only the last column. she can check your books may only go to 60, but I want you these last columns. That's like 13 problems. Okay. So whether it goes to 60 or 66, my version may be slightly different than yours. But yeah, 27, that year, the exercise 6.2, 27, all the way that last column to the end of the page should be about between 12 and 13 problems. All right. Thank you so much. God bless. And I will see y'all tomorrow.